It started, as many cosmic discoveries do, with a flicker of faint smudge on the edge of a vast data stream, nearly dismissed by the algorithms that process terabytes of space imagery every day. But one researcher, scanning through observations from the JamesWebb Space Telescope, paused. What they were looking at didn't fit. The signal was too faint, too redshifted, and yet too structured to be known. It hinted at a galaxy that shouldn't exist, not at that distance, not at that age, not with that kind of luminosity. The universe has a way of surprising us. But this was different. The data was rerun. The signal confirmed. A galaxy glowing from the edge of space had been detected, one so far away that the light we are seeing now began its journey. Just a few 100 million years after the Big Bang itself, this galaxy, designated by a cold and technical alphanumeric code, might be the oldest and most distant object humanity has ever seen. But its discovery has done more than just stretch the boundary of what we thought was possible. It has shaken the very foundations of cosmology. Because in its core, in the brightness of its spiral arms, in the unexpected presence of heavy elements and complex structures, lie questions that our models can't easily answer. How could something so organized, so luminous, so mature-looking, exist in an era of the universe we believed was still in chaos? It challenges the timeline of galaxy formation, the rules of cosmic evolution, and even the age of the universe as we understand it. Astronomers expected early galaxies to be small, clumpy, and primitive faint smears of hydrogen gas slowly coalescing under gravity. But this galaxy, sitting some 30.5 billion light years away, is anything but. It radiates with energy, with mass, with surprising maturity. It shouldn't be there. It is as if someone skipped the first chapters of the universe's story and jumped straight to the middle. For decades, our standard model of cosmology has held up to scrutiny. The lambda CDM model, incorporating dark matter and dark energy, has helped us understand the large-scale structure of the universe, the cosmic microwave background, and the formation of galaxies. But this detection raises a troubling possibility. What if we're missing something crucial? Imagine peering back in time, seeing a baby photograph of the universe and discovering a full-grown adult staring back at you. That's the level of dissonance scientists are facing. The light from this galaxy has traveled through space for over 13 billion years. But because space itself expands, the galaxy is now much farther away. In fact, its light has been stretched to such extreme redshifts that traditional methods of detection couldn't have found it. Only JamesWebb's unparalleled infrared capabilities could tease out its presence from the blackness. What it revealed wasn't just a speck of ancient light. It was a messenger from a time we barely understand, a riddle wrapped in electromagnetic waves. The scientific community has responded with a mixture of excitement and skepticism. Some argue that perhaps the measurements are off, that the redshift might have been miscalculated, or that gravitational lensing from an unseen cluster might have distorted the signal. But repeated observations, cross-verified with other instruments, are making it harder to dismiss. Each new data point adds weight to the uncomfortable idea that we may have to rewrite key parts of our understanding of the early cosmos. And if this one galaxy exists, it's unlikely to be alone. Already other faint, ancient candidates are emerging from Webb's data, like ghosts of a forgotten era. If a pattern forms, if more galaxies like this one are confirmed, it will mean that complex structure formation occurred far earlier than any simulation predicted. This raises an even deeper question. What forces were at work in the early universe that could have accelerated the birth of stars? The clumping of matter, the ignition of entire galaxies, were the physical laws slightly different in the first few 100 million years? Is our understanding of dark matter incomplete? Could there be a new kind of physics hidden in the very beginning of time? One we've never detected, but that left fingerprints in the oldest light? These are not questions scientists ask lightly. They cut to the core of everything we believe about the universe, how it was born, how it grew, and what it might become. the implications go beyond astrophysics. If the formation of galaxies occurred faster, earlier, or more efficiently than we thought, it alters the timeline of cosmic evolution. It changes when stars first formed, when the first black holes emerged, when planets could have begun forming, and even though it sounds far-fetched when life might have first arisen, because if galaxies were already flourishing just a few 100 million years after the Big Bang, then the raw materials for life, carbon, nitrogen oxide, had been forged much earlier. That means somewhere, far across the universe, ancient civilizations may have had billions of extra years to develop. The cosmic clock, long believed to be fixed, may be running on a schedule we never anticipated. But even as scientists struggled to reconcile theory with observation, the philosophical implications are just as profound. Humanity has always gazed into the sky with a sense of wonder. From ancient civilizations tracking the stars to modern telescopes piercing the veil of time, we've looked outward to find our place. And now, the universe looks back not as an empty, chaotic void, but as a realm of mystery and troubling complexity. This galaxy, so impossibly far, reminds us how little we truly understand. It whispers secrets from the edge of time and asks questions we don't yet know how to answer. For many astronomers, this moment is exhilarating. The boundaries of the known are stretching. We are at the frontier of a new era in cosmology, where each new image from JamesWebb may rewrite textbooks. The questions raised are not a failure of science, but a sign of its vitality. Good science thrives on mystery, and in this galaxy's light, there is no shortage of it. Some have even dared to speculate more wildly. What if there were other mechanisms at play, exotic physics, hidden dimensions, or pre-Big Bang phenomena that left imprints on the observable universe? Could our model of cosmic inflation, the idea that the universe expanded faster than the speed of light in its first tiny fractions of a second, be incomplete? Could there have been multiple inflations or a quantum structure to space-time itself? Others point to the nature of time. What if time, as we perceive it, is not uniform throughout the cosmos? Some fringe theories suggest that time could behave differently in different regions of the universe, meaning that what we see as the early universe might have experienced processes faster than our region of space. While speculative, these ideas are gaining renewed interest because of data like this data. That's simply one T fit into our current puzzle without bending a few pieces. One thing is certain, this discovery is only the beginning. The Webb telescope will continue to scan the skies, collecting echoes from creation itself. And with every new detection, the image of the universe we hold in our minds will sharpen, shift, and perhaps evolve beyond recognition. There's a strange beauty in this uncertainty. The galaxy may not have a name that rolls off the tongue, and it won't sparkle like a star in the night sky, but it matters. It matters because it tells us the universe is deeper, older, and more mysterious than we ever imagined. In a cosmos that spans trillions of galaxies and unfathomable distances, one faint glimmer has cast a long shadow over our understanding. And in that shadow, we're beginning to see the outline of something extraordinary, something that challenges our past, reshapes our present, and might just change the course of our future. As humanity stares at the ancient light of a galaxy that should not exist, it is forced to do what it does best. Wonder at the impossible distances, the ancient light, the ghostly whispers of a cosmic dawn. Wonder at the possibility that everything we thought we knew might be just the first layer of a much deeper reality. This is not the end of the story. It is the first chapter of a new one, written in the language of stars and space across the fabric of time itself. And as the universe continues to reveal its secrets, we will be listening, watching, asking, and above all, imagining what lies just beyond the next horizon. The story of the distant galaxy, barely visible yet immensely provocative, did not end with its discovery. In fact, that was only the spark, the match struck in the darkness of our ignorance. Once the initial findings were verified and confirmed, a quiet storm began to brew behind closed doors, inside conference rooms, and within research institutes around the world. The tension was not about disagreement. It was about something far more: unnerving uncertainty. This wasn't just a cosmic anomaly. It was a potentially paradigm-shifting data point that forced some of the world's top scientists to do what they dread most: revisit the assumptions they'd spent decades building. Late-night calls between observatories, confidential data requests between agencies, and heated debates over the interpretation of redshift. All of it underscored one growing realization: if this galaxy was truly as old and developed as it appeared, then our concept of time, of order, of cosmic cause and effect might need a significant overhaul. There was no consensus on what exactly this meant, only a shared sense that the universe had just become a lot more complicated. But complications breed curiosity, and curiosity drives science. The questions that began to form were unprecedented in their boldness. What if the universe didn't evolve in a straight line? What if there were loops in time, or regions of accelerated development? What if galaxy formation didn't require billions of years of slow aggregation, but could occur in isolated bursts under unique conditions? These ideas were once considered fringe interesting, but unlikely. Yet, here they were, resurfacing with new data, breathing life into them. The implications were staggering. If early galaxies could form in this way, then we may have drastically underestimated the pace and nature of the universe's early expansion. Could inflation, the theorized exponential expansion after the Big Bang, have had variations across space? Could it have left behind islands of cosmic maturity, surrounded by oceans of primitive matter? For decades, cosmic inflation was treated as a uniform process. But now, a few researchers dared to ask, what if it wasn't? Meanwhile, as the academic world scrambled for explanations, another group of thinkers began paying close attention. Theoretical physicists, often unbounded by observational limitations, started to explore wilder scenarios. They considered alternatives to the standard model, some involving brain worlds and multidimensional interactions where gravity or time behave differently at the edges of known physics. One paper, circulated in limited circles before publication, proposed that what we had detected wasn't just an ancient galaxy, it might be a fossilized scar in the structure of space-time itself. Evidence of a transient phase where the rules of physics were different. A window into a short-lived epoch that didn't follow the usual script. Among these bold ideas, one stood out not because of its radicalness, but because of its terrifying simplicity. What if our estimate of the universe's age was wrong? This was more than a crack in the wall, it was a wrecking ball to the foundation. Our current model places the age of the universe at approximately 13.8 billion years, a value derived from the cosmic microwave background, redshift measurements, and models of expansion. But if this galaxy truly formed just 200 million years after the Big Bang, and if it already contains elements like carbon, oxygen, and iron metals forged only in multiple generations of stars, then time itself must have operated differently than we thought. Either the galaxy formed faster than any known process allows, or the beginning of the universe occurred earlier than we currently believe. Astronomers began scouring data archives, reanalyzing previous detections that had been labeled as noise or myth. It turns out this wasn't the first such signal. Several obscure detections, logged over the past decade and left unexplained, now glowed with renewed significance. Perhaps they weren't errors. Perhaps they were overlooked whispers from other ancient objects, waiting patiently for someone to understand them. The timeline of the cosmos, once viewed as a clean progression from simplicity to complexity, now resembled something much more: chaotic and uneven, staggered awakening. At the same time, technological teams began refining their instruments. New software filters were developed to detect ultra-high redshift galaxies that may have been previously dismissed. Every day, petabytes of data flowed in from JamesWebb and its orbiting companions. Supercomputers ran simulations around the clock, trying to recreate the formation of a galaxy like the one detected. None succeeded. The simulations either required an impossibly high density of matter in the early universe, or laws of physics that contradicted other observations. The model strained under the weight of contradiction, like a puzzle that insists the corner pieces are in the center. And then something unexpected happened. A second galaxy appeared. It was not quite as old, but its properties echoed the first. Again, too bright. Again, too massive. Again, signs of chemical maturity where only hydrogen and helium should have been. The scientific community froze. 2 is not a coincidence. 2 is a pattern. The troubling questions multiply. Were these galaxies flukes? Or were they part of a much larger population, hiding just beyond our current observational limit? If so, then the narrative we've built around the early universe might be tragically incomplete. We've always assumed that light travels at a constant speed, that distance equals time, and that the farther we look, the closer we get to the beginning. But what if that's only mostly true? What if certain regions of the early universe had different densities, different particle interactions, or even different gravitational constants? Could these regions act like accelerators, birthing galaxies in cosmic instants? Could they be remnants of earlier universes' bubbles of physics carried over from a previous cycle of creation? These ideas, once confined to the realm of speculative cosmology, are now being discussed at major astrophysicists are collaborating with quantum theorists, trying to merge ideas that have long existed in parallel but separate tracks. The line between science and philosophy is blurring, because at the heart of this mystery lies a terrifying possibility that the universe is not only stranger than we imagine, it may be stranger than we can imagine. Outside of academia, public interest exploded. News outlets began reporting on the discovery with awe and occasional alarm. Headlines asked if we had detected an alien galaxy or if time travel was real. Podcasts debated whether this meant we were living in a simulation. The public's imagination ignited, and with it came a renewed hunger for answers. For once, science fiction and science reality had collided in a moment of cosmic introspection. And while the more outlandish theories were quickly dismissed, their emotional power was undeniable. Humanity, after all, wants to know where it came from. And if the past we thought we knew was different, then the future we imagine must be too. Meanwhile, a small group of scientists working in Antarctica's Neutrino Observatory began asking a different question. They wondered if the particles from such early cosmic rays or gravitational waves might already be passing through Earth, undetected or misinterpreted. Could the answer be buried beneath our feet in silent particles streaming through the planet from these ancient sources? It was a tantalizing idea, one that led to proposals for new detectors, deep space observatories, and cross-disciplinary missions that could marry cosmology with quantum theory in a way never attempted before. Back in orbit, the JamesWebb team was already pushing the limit. Engineers initiated a deep scan protocol targeting sections of the sky considered too faint for previous surveys. In those dark pockets, more galaxies emerged. Faint, ancient, scattered across the void like embers from a dying fire, but burning all the same. The darkness was no longer empty. It was full of history, waiting to be read. One by one, they were cataloged, their redshifts measured, their spectra analyzed. And with each new discovery, the models grew more unstable. The universe, it seemed, was less a linear unfolding and more a turbulent sea of possibility. The implications crept into other fields. Planetary science began to re-examine when habitable worlds could have formed. Exoplanet hunters recalculated the probability of ancient If complex galaxies existed so early, then the first stars may have lived and died fast enough to seed planets with life's essential ingredients far earlier than previously believed. Astrobiologists began to consider a sobering thought. Maybe the universe had already passed its biological prime. Maybe we're late to the party, observers in a cosmos that once teemed with life billions of years before Earth formed. And then came the most controversial suggestion of all. A team based in Japan proposed that these galaxies were not simply ancient. They were echoes from another cycle. In this model, the universe undergoes endless expansions and contractions. Each time it bounces, some memory of the previous cosmos is retained. These early galaxies, then, might be survivors of a past universe resurrected through gravitational loops or quantum echo. It was bold, but it captured the imagination like nothing else. We are left, then, not with answers, but with deeper, sharper questions. What kind of universe allows for such early complexity? Is there a master blueprint that we have yet to decipher? Or is the cosmos improvising, adapting, experimenting across billions of years and billions of light? In the flicker of these ancient galaxies, we see not just light from the past, we see ourselves, our own desire to understand, to reach beyond what is visible, to trace the threads of existence back to their origin. The universe has handed us a riddle, and it will not be solved as such. It demands patience, creativity, and the humility to admit what we don't know. And yet, this is what makes the journey worth it. Because hidden in the quiet glow of those impossibly distant galaxies is a message not just about stars and time, but about human curiosity and the infinite paths it dares to walk. For weeks, the newly detected galaxies became the center of a silent revolution in astrophysics. The world outside remained largely unaware of the intellectual earthquake shaking the foundations of cosmology. But within research institutions, the gravity of what was unfolding could no longer be contained. The story had outgrown its original scope. What began as a remarkable detection of one impossibly distant galaxy had become a haunting pattern. Multiple ancient galaxies, each older and brighter than they had any right to be, each one challenging the timeline of creation. The known universe, once charted with scholarly certainty, now seemed to possess deep blind spots, regions where the rules folded in on themselves, forming a hidden architecture no one had anticipated. While telescopes scanned the skies and algorithms parsed the data, a different kind of investigation was quietly underway. Teams of physicists and mathematicians, drawn by the irresistible pull of the unexplained, began to draft theoretical frameworks not based on what had been observed, but on what could logically allow such galaxies to exist. It was here, in this realm of disciplined speculation, that the most audacious questions emerged, not about where or when, but how? One proposed model suggested that these galaxies might have originated from zones of accelerated entropy, where time under specific conditions moved at an unequal pace. These were dubbed temporal wells, hypothetical regions in the early universe where space-time, warped by massive energy differentials, allowed pockets of rapid evolution. In such wells, matter could condense and organize far quicker than the surrounding universe. The idea was elegant, even poetic, galaxies blooming in the cracks of cosmic turbulence, but proving it would require data that no telescope could currently provide. Still, the theory spread, gaining both critics and cautious supporters. Elsewhere, quantum physicists took a different approach. They theorized that what was being observed might not even belong entirely to our universe. Instead, these galaxies could be projections, quantum mirages generated by overlapping realities. The multiverse, once considered fringe science, was back in focus. If alternate timelines or dimensions pressed against our own at the moment of the Big Bang, perhaps energy and matter bled through briefly, leaving behind structures that carried the signature of elsewhere. These ghost galaxies, as some began to call them, might be literal echoes from another cosmos. It was an eerie thought, one that reframed the mystery not as a flaw in our understanding, but as evidence that our universe was never alone to begin with. Amid these dizzying possibilities, something far more grounded occurred. An anomaly in the spectrum data of one of the galaxies. At first, it seemed like a computational error. A repeating signal embedded faintly in the frequency spread of ionized oxygen seemed irregular to patterned. Spectral lines should be chaotic and organic, the result of random atomic interactions over billions of years. But this pattern, this whisper, was neither random nor natural. It pulsed with rhythm. Some dismissed it as interference, a glitch in the processing software. Others weren't so sure. A small international team quietly began reanalyzing the raw data. They stripped the compression algorithms, checked for reflection noise, ran the signal through every conceivable filter. Still, it remained a subtle beat hidden in the light from a galaxy over 13 billion years away. What could cause such order in such a distant place? No known process could. That left a terrifying question. Was it artificial? The idea was dangerous. If word got out that scientists were discussing intelligent origins, the entire investigation could be derailed. Funding might vanish. Reputations could suffer. So the team worked in secret. For weeks, they simulated all known physical phenomena. Gravitational lensing, nebula fluctuations too. See if any natural source could mimic the signal. None matched. And then something even stranger happened. The same pattern was found faintly in two other galaxies, separated by millions of light years and appearing in different areas of the sky. They all shared this spectral fingerprint. Somehow, light from different corners of the ancient cosmos was humming the same tune. Whispers spread through the astrophysical community. Some began calling it the song. It became an unspoken code among those studying the time inside, reference to the growing mystery none could fully explain. Was it a cosmic coincidence? A repeating quirk of some unknown early universe chemistry? Or was it deliberate? Theories blossomed like stars. One astrophysicist suggested the signal was a naturally occurring constant of early galactic formation, a kind of quantum fingerprint left behind by the birth of matter. But another group, far more radical, proposed that it was a marker, a beacon. In ancient myths across cultures, people told stories of gods and messengers who left signs in the stars, symbols carved in light to show the way. To the more imaginative minds among the research teams, the song felt disturbingly similar. Not just a clue, but a calling card. If true, the implications were it meant that, at the very dawn of time, someone or something was capable of encoding information into light. Not only that, but they had done it across vast distances, in galaxies born before our own sun existed. But how? And why? Speculation shifted again. Perhaps the signal wasn't recent. Perhaps it was baked into the structure of the universe itself. One theory posited that this pattern was a byproduct of the first symmetry break, the moment when the universe split from a unified force into the four fundamental forces we now observe. This break may have imprinted itself onto the fabric of reality, creating harmonic frequencies still echoing in high redshift light. If that were true, the song wasn't artificial at all. It was the original note of creation, a literal chord struck by the Big Bang, frozen into the light of the earliest galaxies. Still, the regularity remained unsettling. It was too clean, too intentional. The cosmic background had never exhibited such precise repetition. As debate surged, powerful AI models were brought into the fold, trained on everything from cosmological simulations to signal recognition software used by intelligence agencies. The AIs were tasked with decoding the song. After weeks of analysis, one model flagged a structure, not language, but logic. The signal bore a resemblance to mathematical constants, ratios, and sequences that transcended culture, biology, or origin. Pi, phi, the Fibonacci sequence. It was as if the light itself was whispering in mathematica. Universal tongue meant for anyone advanced enough to listen. For the first time, the team faced a possibility they had dared not speak aloud. This could be a message. Not a message in the traditional sense, not words or comments, but a demonstration. A mathematical greeting. An indication that intelligence, or at least consciousness, had existed at a time when the universe was still forming. If that were true, then humanity was staring not just into deep space, but into the eyes of its own cosmic ancestors. News of the signal, now leaked by an anonymous source, reached the public domain. It ignited the media like a flare in dry brush. Theories spiraled ancient, civilizations, godlike architects, time-traveling engineers. Documentaries were forums buzzed with obsession. And while many dismissed it as hype, the pressure on scientists to respond became overwhelming. A public statement had to be made, so they did but carefully. They confirmed the existence of the repeating spectral pattern. They acknowledged its mystery, but they offered no conclusions. The universe, they said, was full of strange music. And perhaps, sometimes, the notes only seemed deliberate. It was a diplomatic answer, one designed to calm curiosity without extinguishing it. Privately, the researchers were far less composed. In hidden reports and encrypted communications, they admitted what they could not say publicly, that this discovery, if understood, might redefine humanity's place in the cosmos, that it might point not just to intelligence, but to a deeper structure underlying all of existence, designed more intricate than anything they'd imagined. Months passed. Observatories refined their instrument. A new telescope already in development was fast-tracked to launch equipped with the sensitivity needed to map ancient light in detail never before possible. Its mission was clear: follow the song to its source. But deep down, many feared what that search might uncover, because the troubling questions had changed. They were no longer about the age of the galaxies. They were about intention, about purpose, about whether the universe in its oldest corners still carried the fingerprints of beings who had moved on, or were still watching. And if they were watching, the most disturbing question of all remained unspoken. What were they waiting for?